Hey guys, it's Anna. I'm back with some more examples to help you out putting equations in slope-intercept form. So a lot of the problems that you're going to see in your book are just really simple and easy. A lot of them don't have messy fractions in them, and it can be really a challenge to make the jump from doing super easy practice problems and then on test day, lo and behold, there's all these fractions, there's all these weird numbers everywhere. It's like so much harder, and I'd always be like, come on, why don't you put some more difficult examples in the textbook so it could kind of help me out, help me get ready for the test. So that's what I want to do in some of these videos, is show you some harder examples, more challenging examples. And I want to be clear, when I say harder, I mean that it just requires more steps. So I like to almost never say the word more difficult or harder to my tutoring students. I like to just say this problem requires more steps than some of the other problems you've done. It just requires more steps. It's not necessarily harder or more difficult. Whenever I used to hear teachers say like, this problem is really hard, I always would think like, is that because you don't really know how to do it super well? Like, for your job is to make it easy for me as a teacher. And so sometimes though there are problems that require more steps, and sometimes those are the ones we think of as harder, but not really that harder, just require a few more steps. So let's take a look at this one. We want to put it in slope-intercept form. So you can go watch some of my other videos on how to write a basic equation in slope-intercept form, maybe how to convert from standard form into slope-intercept form. But we know that slope-intercept form is y equals mx plus b. So that is really important to know. The m is the slope, the b is the y-intercept, and getting an equation in slope-intercept form requires you to be able to isolate the y by itself, to isolate the variable. It's a lot of what we do in algebra is just isolating variables. So we want to look at what's happening to the y right now. Right now, the y is being multiplied by 12, right? And then we have a couple other things going on. We have this fraction over here. Now, I like to start, there's a couple different ways we could start. So some people would think about starting by dividing by 12, but we're already dividing by 3 over here, and that would be kind of messy. So I like to only be dividing by one thing at a time. So the first thing I'm going to do is I'm going to get rid of this fraction. So right now, how do we get rid of this fraction? Well, the fraction is because we're dividing by 3. And so we want to get rid of that. We're going to ask ourselves, what's the opposite then of dividing by 3? So what is the opposite of dividing by 3? Multiplying by 3, right? So what we're going to do is we're going to multiply by 3 over 1 on both sides, because what you do to one side, you must do to the other. Okay, so when we multiply by 3 over here, the 3 on the top, 3 on the bottom, this converts to 1. So these 3's cancel, because 3 over 3 is just 1. And then we're left with just our regular 8x minus 48 on the top, because this is all over 1, equals 12 times 3 over 1. So 12 times 3 is 36, and we still have our y. So now we've gotten rid of our 3, our fraction. So now we're only, when we go to divide, we're only going to be dividing by one thing at a time, which is going to be really, really nice. Okay, so now we're asking ourselves still what's happening to y. Y is being multiplied by 36. We want to get y by itself. We notice over here mx plus b, we have something x minus something. It's already looking like it's nicely getting close to y-intercept form. We just got to get y by itself. So the opposite of multiplying by 36 is dividing by 36. So we're gonna divide by 36 on both sides. What we do to one side must do to the other, right? So now we have y, the 36 divided by 36 goes to 1. So y equals, we have 8x over 36 minus 48 over 36. And we're gonna see if we can simplify these fractions further. So let's think about it. So what goes into both 8 and 36? I would like to just try dividing them both by 2, splitting them both in half, right? So let's try that. So we can do y equals 8 divided by 2 is 4, so 4x over, and 36 divided by 2, so 30 divided by 2 is 15, right? And 6 divided by 2 is 3. So we're going to do 15 plus 3, which is 18. And then minus 48, if we split that in half, we split the 4 in half, we get 2. We split the 8 in half, we get 4, so we get 24. And 36, we know it's 18. Still doesn't look like it's in simplest form. Looks like we can take it down a little bit more. Let's split it again. Y equals, if we split it by 2, 2x over 9, because half of 4 is 2, half of 18 is 9. Minus 24, split it in half, we get 12. Split the 18 in half, we get 9. Can we do it one more time? It looks like we can do this one more time. So y equals 2x over 9. This one we've maxed out. But then minus 12, we can divide these both by 3, right? 12 divided by 3 is 4, and 9 divided by 3 is 3. So 4 over 3, or 1 1/3 if we wanted to write it as a mixed number. This is how you write it in simplest form, in slope-intercept form. So what is the slope? The slope is 2 over 9. What is the y-intercept? The y-intercept is 4 over 3, and we can say 4 over 3 is going to be 1.333, repeating, 1 1/3. So you'd go to 1 1/3 on the y-axis, and then to do the rise over run, you'd rise 2, you'd run 9, 2 over 9. So sorry, I'm kind of in the way of the writing, but this is how you put an equation like this into slope-intercept form. I'd recommend getting rid of your fractions first, then see what's happening to y, do the opposite. Here it's being multiplied by 36, we're gonna do the opposite. We're gonna divide by 36 on both sides. Go ahead and simplify on down. Hope this was helpful. Can't wait to see you again soon.